Okay, so this is some work I've been doing with my CIMAS and colleagues as part of a multi-year project to assimilate and optimize the use of all tropical cyclone observations in the HAFS model. So why is this important? Well, creating a good forecast, just like baking a cake, requires more than just having good ingredients, in this case, our model and our observations. And a good chef, which is our data assimilation system that combines the models and the observations, we need to have a good recipe. And that includes new instruments and sampling strategies, quality control, thinning or superobbing data to improve representativeness, finding the ideal mixture of data, identifying filling data gaps, improving resolution, and testing and refining through data impact experiments and error optimization. So how do we go about improving this recipe? So on the far right, we can evaluate new platforms with respect to existing well-tested platforms, such as comparing small uncrewed aircraft temperature on top with dropsonde and wind speeds with tail Doppler radar. We test assimilating these new observations. In the center there, we're assimilating both uncrewed aircraft and sail drones and ocean drifters. On top left, we're identify outlier data by comparing all available observations to each other, not just with the model. And then we are able to improve representativeness and assimilate more observations from voluminous data sets by creating super observations, combining observations together. And then, of course, we have to create improved diagnostics in order to understand the effect of all our tweaks to our recipe. And so here are some of the results. So we have incremental improvements to forecasts by assimilating super observations of tail Doppler radar on the right, and on the upper left, super observations from dropsondes. In the center, we get improvement by filling data gaps by using sail drones and small uncrewed aircraft. And then we see how better quality control produces a better fit of the model to the observations. And then finally, up top, we show that through all these experiments, we're actually improving how we use the aircraft to collect better data and further refine our recipe. And in the end, we all get to eat cake.